In this demo, we will discuss about nested loops and the prefetch mechanism. I'm going to use database AdventureWorks DW for this demo. I'm going to create two tables, table 1 and table 1 underscore temp and table 2 underscore temp. Table 1 underscore temp will have close to 10,000 rows and the data will be coming from a table called table 1. Likewise, for table 2 underscore temp, it will be having close to 10,000 rows and the data will be coming from a table 1. Now I'm going to insert some random rows across these two tables. We will have some random rows inserted into table 1 underscore temp and table 2 underscore temp. I'm using a while clause to perform this, and if you look at it here, what I'm basically doing is like I'm inserting close to 24 rows with this value in table 1 underscore temp, close to 200 rows into table 1 underscore temp with this value, and close to 26 rows with this values to on table 1 underscore temp. Likewise, I'm inserting same number of rows with the values on table 2 underscore temp as well. So let's execute that. Once the insert is completed, I'm going to create an index called ix underscore test1 on table 1 underscore temp on column 1. And as far as table 2 underscore temp is concerned, I will be creating a non-cluster index ix test1 on column 3, and then I'll be including column 1 and column 2. I'm going to create a stored procedure called sp underscore table 1 underscore temp. Stored procedure sp underscore table 1 underscore temp has a parameter at column 3 integer. So this stored procedure basically selects column 1 and column 2 from table 1 underscore temp and table 2 underscore temp respectively. We are inner joining table 1 underscore temp and table 2 underscore temp, and the join condition is column 1 on each of these tables. The predicate is basically we are having table 2 underscore temp dot column 3, and it is compared with the parameter value of this stored procedure, which is at call 3. So let's execute this query. And now what I'm going to do is like I'm going to include the actual execution plan, and then I'm going to execute all these three stored procedure execution. So let's execute that. So the execution completed, and what I'm able to see is like the first execution returned close to 24 rows, second execution returned close to 26 rows, and then the third execution returned close to 200 rows. And now if I look at the execution plan, what I'm able to see is like I'm able to see we have an index seek on table 2 underscore temp, and we are estimating close to 24 rows, and we are reading close to 24 rows, and then we are returning 24 rows. And as far as table 1 underscore temp, we again have an index seek, and here as well we are estimating 24 rows. We are reading close to 24 rows and returning 24 rows. Now, if you look at it here, we basically have a nested loop that basically joins the data from each of these tables. And if I look at the properties of this particular nested loop, what I'm able to see is like we don't have anything related to prefetch as far as this nested loop is concerned. So let's look at the execution plan for the second execution of this stored procedure. And what I'm seeing is like here we are estimating 24 rows, we are reading 26 rows and then returning 26 rows. And this is same for the index seek on table 1 underscore temp, where we are estimating close to 24 rows and we are reading 26 rows and returning 26 rows. Notice we have a lower estimate. This is because like we are reusing the execution plan from the previous execution. If we look at the parameter list, we'll be able to understand like this stored procedure would have been compiled as far as the plan is concerned. It was compiled using the value of the previous execution. Now we look at the parameter list. If you see here, the compiled value is 990 and the runtime value is 0. So that's the reason we are using the same plan. And the third execution, if you look at the table 2 underscore temp index seek, what we are able to see is like we have a lower estimate again. 24 rows is estimated. We are reading 200 rows and returning 200 rows. Likewise, here also we are estimating 24 rows and reading 200 rows and then returning 200 rows. So this is what it is right now with the nested loop, and as far as the execution is concerned. What we'll do now is like we will free up the procedure cache. This is a lab machine, so I'm doing that. We can't do it on the production server, but as far as this demo, this is happening on a lab machine, so I'm doing that. So I have freed up the procedure cache. Now, any successive execution of this stored procedure is going to create a new plan. So let me execute it. Looking at the execution plan, what I'm able to see is like the plan is same as the previous execution. I don't think there is any change as far as the plans are concerned. Now, if we look at the index seek that is happening on table 2 underscore temp, what I'm able to see is like we are estimating 26 rows, we are reading 26 rows and returning 26 rows. The only difference is like last time we used you use the parameter 990 first after creating the stored procedure, but this time we are using the parameter 0 for first time. That is like the procedure that is created here basically uses this value 0. If you look at the parameter list, the compiled value and the runtime value is 0. So that means like this procedure's execution plan is basically compiled using this particular value, which is 0. Now we know that it is estimating close to 26 rows. It is reading 26 rows and returning 26 rows. Likewise, if we look at other execution, here we are basically estimating 26 rows. There is a higher estimate. We are estimating 26 rows, returning 24 rows. And for table 1 underscore temp, it is same. We are estimating 26 rows and returning 24 rows. The third execution, we are estimating 26 rows, reading 200 rows and returning 200 rows. And that is same here as well. So it is same as the previous execution plan, the previous execution where we used 990 parameter value for the first time after creating the stored procedure. The only difference is like the previous execution had uh, um, an estimate of 24, but this one basically has an estimate of 26 if we look at this. But the important thing to note here is like let's look at the nested loops here. If I look at the nested loops, what we are able to see is like we have something called with unordered prefetch, which is set to true. So previously we did not see that, but in this execution, what we are able to see is like this with unordered prefetch is set to true. So prefetch, what does that mean? Prefetch is a mechanism with which SQL Server can fire up to many IO requests in parallel for nested loop join. So it is basically like when this prefetch is enabled, SQL Server gets the capability to fire up several IO requests in parallel for nested loop join. And when things happens in parallel, what happens is like the performance also improves to a greater extent. And when SQL Server estimates less than 25 rows for the outer input table, prefetch will basically be disabled. So that's the reason last time that is last time in the sense like when we executed with this set of stored procedures, like with this parameter value, we estimated close to 24 and we were not able to see unordered prefetch set to true. But as soon as we estimated close to 26 rows, we were able to see that prefetch option was enabled. So nested loops, if a prefetch is enabled, it allows SQL Server to fire several IOs requests in parallel for nested loop, and that is going to really improve the performance. Now what we'll do is like we will free up the procedure cache one more time, and then now I'm going to reverse the order altogether, wherein what I'm going to do is like I'm going to use the parameter value 10,000 for the first execution. So let's run that. if you see here, we are estimating 200 rows, and then we are reading 200 rows and then returning 200 rows. For the second execution, it is a higher estimate wherein we are estimating 200 rows and returning 24 rows. And for the third execution, again, it's going to be an overestimate where we estimate 200 rows, read 26 rows, and return 26 rows. Now, if you look at the nested loops, you'll able to see that with unordered prefetch option is set to true. So what we understand here is like in case if the estimate as far as the outer input table is concerned, if it is below 25 rows, then what happens is like prefetch is not enabled. In case if it is over 25, then prefetch is basically enabled, and 25 is the sweet value as far as enabling and disabling prefetch. For example, if it is higher than 25, it gets enabled. If it is lower than 25, then it basically gets disabled. So what we are going to do now is like we can add a recompile hint to the stored procedure. What we'll do is like we will alter the stored procedure sp underscore table one underscore temp, and then we will add a recompile hint. Once this is added, what we'll do is like we will execute each of these stored procedures with different parameters. And what I'm able to see for the first one, I'm able to see that we have close to 26 rows estimated. So in this case, we have unordered prefetch enabled. And for the second one, we have close to 24 rows estimated. So now we look at the nested loops, prefetch is not enabled. And for the third execution, we are estimating 200 rows. And now you look at the nested loops, unordered prefetch is enabled here as well. For example, we have added this recompile hint, and let's consider if this stored procedure is going to execute several times in a second, and in case if it is going to have an CPU contention, then what we can do is like we can try adding an hint called optimize for. So if you see here, what I'm basically doing is like we know that as far as the execution parameter 0 is concerned, we are estimating close to 26. So what I'm going to do is like I'm going to alter the stored procedure and then going to add this hint called option, optimize for column 3 equal to 0. So what will happen is like you will catch the estimate as far as any execution is concerned. You will get the estimates when the parameter column 3 equal to 0 is called. So let's execute that. And then if we execute this particular stored procedure with different parameters, looking at the execution, the first one is basically 0. If you look at it, it's going to estimate 26 rows for all the execution, no matter what parameter values you have. So if you see here, it is estimating 26 rows. Even in this execution, you will see that it is estimating 26 rows, and it is reading close to 200 rows. So what we are basically doing is like we are we for this particular stored procedure modification, we added this optimize for and advised the optimizer that let the estimate be used as far as the value column 3 is equal to 0 is concerned for all the execution. And this way we were able to enable with unordered prefetch equal to true for all the 3 executions. But the thing is like it is basically taking away the capability of estimating each and every query as far as the optimizer is concerned. That's it for this video. Thanks for watching. Have a great day. Jai Hind.